Hi and welcome. I can see that the first people are joining in. So hi, nice to meet you. Welcome to this masterclass in partnership with Syracuse University. My name is Stefania and it is a pleasure for me to be here. I will be moderating this webinar on behalf of Docsity. So in the meantime that we are waiting that all the people are joining in, I will ask to the ones that are connected to pop up in the chat, where are you from, just to know something about you. And once again, it's a pleasure for me to welcome you to this masterclass in partnership with Syracuse University. This masterclass is dedicated to ChatGPT-Assisted Techniques. And I'm asking you if you want to type in the Q&A box. We will be happy to read the questions after the presentation. And we encourage you to do it because at the end, in this way, we can just talk about it since this is a really interesting topic. Here with me, there is the Professor Harter, the Director for Business Analytics at the Whitman School of Management at Syracuse University. And this session, this masterclass, will demonstrate traditional approaches and ChatGPT-assisted technique to solve problems and identify the strengths and weaknesses of ChatGPT for analytics. We know that you all are here because you are interested in this topic and also because it's really very topical. And you probably have questions about the future of ChatGPT and artificial intelligence. Maybe you're wondering, will it be used for a long time, or it will be replace some jobs, it will make our lives easier or not? So we will discover it during this masterclass, and these are just some words to make you think about this. In this way, you can just type in the chat if you have some questions about it. So feel free to use the chat. And for the last time, since we have already a few participants, it's my pleasure to welcome you today. My name is Stefania, and I will be moderating this webinar on behalf of Docsity. This is a masterclass dedicated to ChatGPT-assisted techniques. And for those of you that are still joining us, I would like you to introduce you the Professor Harter, Director for Business Analytics at the Whitman School of Management at Syracuse University. Thank you for your presence here today, Professor. And at this point, I think that you can start your presentation. I will leave the floor to you. And just enjoy the presentation and keep in mind to write your questions in the Q&A box, and we will reply to you soon. So Donald, the floor is yours.
Great, thank you for the introduction. For everybody in the audience, good morning, good afternoon, or good evening, depending on where you're located. My name is Don Harter. As was mentioned, I'm the Director of Business Analytics at the Syracuse University's Whitman School of Management. My topic today is going to talk about ChatGPT assisted techniques, particularly for analytics and how to apply them to analytics. If I speak too fast today, let me know in the chat. I'll try to slow down. If I'm not clear on something, feel free to ask questions. And so what I want to do today is give you a very brief history of about 5 or 6 minutes or so of the history of AI, of how we got to the point we are today with ChatGPT. Then talk about what ChatGPT is, how does it work. I have some scripted examples of ChatGPT applied to analytics, and we'll actually run those on the platform today. I will give you a caveat. ChatGPT is available 24 hours a day, but during peak times, it might slow down. So I've actually saved copies of all the things I'm going to show you. And if necessary, I'll go to my copies to demonstrate what was actually run in just the last 24 hours. Then I'll talk about some strengths and weaknesses of ChatGPT. The technology is a step forward in assisting you in doing your jobs, but there are some issues with it. If you know what those issues are, you can work around those issues, and I'll show you how to work around them. A lot of research has been done in the last year or so on productivity improvements as a result of tools like ChatGPT. And we'll end with basically a discussion of what people are seeing in terms of the improvements to their jobs, to their productivity, and so forth. So that's the outline for today. So I'm going to take you back, a long way back, to 1957, over 65 years ago. The first attempt to do something along these lines was created by a gentleman named Frank Rosenblatt. He was at Cornell University, and in 1957, he said he wanted to try to classify data as to being yes or no. For example, if someone walks into a car dealership and you know their age and you know their income, can you predict whether they're going to buy a Lexus or not? In this example, I've coded the events up here in the red triangles. Give me for a second. I got to share my screen. So in this example, Frank Rosenblatt created linear perceptrons. I've coded some data points up here as people who bought a Lexus. I've coded data points down here of people who did not buy the Lexus. And across the bottom, I have their age. Across the side, I have their income. And if you notice a pattern, people with lower incomes don't tend to buy a Lexus. People with higher incomes do. There's also another pattern. As people get older, it doesn't require as much income to necessarily buy a Lexus. And so this is what I call the midlife crisis. Older people start to say they don't care what it costs, they'll buy it anyway. Now, why is this important? If you are an owner of a car dealership and you know someone's age and their income, you can start to predict whether or not they're going to buy a car or not, so you know who to spend time with. Rosenblatt's technique, called linear perceptrons, drew a straight line separating the people who purchase and the people who don't. And if you can figure out those patterns, you can decide you spend time with these customers, you won't spend time with those customers. From 1957 to the late 1960s, this was state-of-the-art in artificial intelligence until 1969 at MIT, Marvin Minsky and Seymour Papert wrote a paper that said there's a flaw in this technique. In mathematics and computer science, it can be proven that if you can do what's called an AND condition, an OR condition, and an exclusive OR, you can replicate almost any mathematical formulation. They were able to prove perceptrons could not solve the exclusive OR problem. As a result, linear perceptrons fell out of favor. And for the next 15 years or so, the field of artificial intelligence sort of crashed. But in the mid-1980s, a number of researchers, Jeff Hinton, Rumelhart, McClellan, and others, came up with the idea of neural networks. A neural network added a hidden layer between the inputs and the outputs and replaced the linear function, that straight line, with a sigmoid, our nonlinear function. The most popular one is often the logistic function, which gives you this S-shaped curve. By doing that, by doing those two things, by introducing a hidden layer before the outputs and changing it from a linear function to a nonlinear function, we now have neural networks. Neural networks are much more successful at being able to analyze data. And some of the first applications of neural networks in the late 80s and early 90s, Carnegie Mellon actually used it to develop the first autonomous vehicle, the first self-driving car. They used a simple neural network with pixels of the roadway, one hidden layer, and driving direction as the outputs. And under a grant with Defense Advanced Research Project Agency, they were able to demonstrate in 1992 the first self-driving car using simple neural network running on a computer in the back of the vehicle. Now, that neural network research has expanded. And how does it work? Let's talk about how it works first. It uses a technique called gradient search. This is going to be important in our discussion for ChatGPT. In gradient search, you might have curves that look like this, and you're trying to find what's the highest peak. You randomly start at some random starting point, such as here. You calculate which way is up. It's called gradient search or hill climbing, and take a step in that direction. Recalculate which way is up, and keep taking steps until you get to the top of the hill. The challenge is this hill might not be the highest hill. There might be a higher one back here or over here. And so one of the challenges of neural networks is what's called local optima. Local optima basically says it's getting stuck at a solution that is not the best solution. So let's look at an extension. It's called deep learning. Deep learning is a neural network with multiple hidden layers. And it looks like this. We have our inputs again. We have multiple layers, hidden layers, before we have our outputs. Inside is that sigmoid or logistic function. A number of functions can be used there. In this example, I've used a logistic function. And when you have additional hidden layers, this takes us closer to ChatGPT. It allows you to do what's called language learning. In language learning, in the 1990s, the mid-1990s, Carnegie Mellon University was doing language learning on the language of English, learning how to recognize spoken English. By the late 1990s, they were actually transitioning to Korean to see if they could do multiple languages. In 2010, Siri was actually released as an app you could install on your phone. It was actually part of the iPhone in 2011 and part of iPads in 2012. Siri uses deep learning, multiple hidden layers, to do language learning, which allows Siri to recognize spoken speech and generate speech back. So how does that relate to ChatGPT? Well, OpenAI, the organization that created it, was actually created back in 2015. And they used a unique strategy. Strategy was hire the best researchers in the field. And they hired the 9 best people in artificial intelligence around the world. ChatGPT itself is a large language model. It's based on that deep learning that I showed you before, that basically learns language and then extends it from there. GPT-3 GPT-3 was released in 2020. ChatGPT 3.5, which received a lot of publicity, was released in November 2022. It used supervised learning and reinforcement learning. Supervised learning, you know the outcome. Reinforcement learning allows you to add weights and rewards to improve the learning. The current version of ChatGPT learned from over 45 terabytes of text data and was polished and assisted with human trainers. A pattern that I've noticed in actually using ChatGPT for analytics, it tends to remember what you did previously. So as it's actually doing analytics solutions, it remembered what you did in previous requests to actually perform ChatGPT. As a result, you have to keep that in mind because it'll be somewhat biased by what it's done before. So I want to walk through some examples with you. The first example we're going to look at is called the iris dataset. Iris is a flower, and there are 3 different species of iris. The picture over here on the left is called Iris versicolor, Iris setosa, and Iris virginica. The species can be identified by what's called the sepal and the petal. And if you measure the sepal width and sepal length, and the petal length and petal width, and compare those, you can actually start to classify irises into different species. This data set is actually from the University of California Irvine Machine Learning Repository, where they collected 150 samples, 50 versicolor, 50 setosa, 50 virginica as their sample data set. And we're going to see if we can actually use that and graph the data and then start performing analytics on the data. So in a moment, I'm going to actually start using ChatGPT to generate information on how to use these techniques. A caution, ChatGPT is generally available if in fact we run into unavailability issues. During peak times, it becomes stressed and sometimes doesn't respond to the system. The system does not respond. As a result, I've actually created a document with all the results, and I'll walk you through that. Another caution, every time you run ChatGPT, it gives you slightly different answers. Generally, the answers work. Sometimes they don't. We'll actually discuss that and walk through that. So let's start using some examples. And I'm going to go to ChatGPT. This is what ChatGPT looks like. You simply go to the website openai.com/blog/ChatGPT. If you click on ChatGPT, there's a login procedure. You can sign up for a free account. There are also accounts where you can actually pay for access. I'm going to use a free account here. And when I click on Try ChatGPT, it brings up a window that looks like this. And it gives different examples at the top. But the part we're going to use today is down here at the bottom. And we can actually send a message to ChatGPT. What we're going to do is send it a message and have it generate some R code for us. I'm going to actually be using the R package. Let me show you what R looks like. R is a statistical analysis, data mining, and machine learning package. And we're going to use R to actually do some analysis on some data sets. First on the iris data set. And so, as my backup, I'll show you what I'm working with on the side. I actually have all my notes here on what we're going to request ChatGPT to do, what we expect the answer to look like, and so forth. And so I'm going to ask ChatGPT to generate a graphic that allows us viewers to get an overview of the iris data set. Notice I've put something specific in here. I know R, and I know I wanted to use what's called the ggplot2 graphics package. I'll show you some cases where we put in vague requests and more specific requests. The more specific you are, the more accurate your response is going to be. So let's put in generate R code for a ggplot graphic that allows viewers to get an overview of the iris data set. And I'm going to copy that in to send a message. And it takes some time to process. Notice here's our request. If we're at a peak time and we can't get a response, I actually have what the response is. And we'll see, we'll give it a second to process. In the US, we're in the late morning right now, so ChatGPT is rather busy. And we'll see if it comes back soon. If it doesn't, I've actually got the code that it generated for me just yesterday. Now, I generally run this in non-peak times in order to get faster response. And looks like I'm going to have to actually use my example. And so here's the example it comes up with. It'll actually come back with a screen that says, here's an example of a ggplot plot graphic, provides an overview of the iris data set. It says this code creates a scatter plot of sepal length and sepal width. And it lists the code for you. There on the screen is a button that says copy code. If you click that button, it'll copy it for you so you can install it. Now, let me show you a weakness. It's going to use the ggplot package, but you actually have to first install it. I installed this package earlier today, so I won't have to do that. And then the commands that you see here on the screen I've copied down here, so I can just copy those over. So it looks like we have an error. We're going to try to regenerate the response. I'm going to go to R and actually take my earlier response. And let's take the code that I generated yesterday and run it. And it automatically writes the code and generates this graph. In this graph, if you look at it closely, over on the right side, it says the species Setosa is color-coded red. It's these data points. It tends to be sepal width in higher numbers. In the green are some data points through here, which is versicolor. The blue are over here. Let's look at what that code looks like one more time. And we'll go back for a second. ChatGPT is now working and it's responding by saying, certainly the iris data set's a popular data set. Here's an example of the R code using ggplot2 to create a scatter plot matrix that provides an overview of the iris data set. Now, the system is very overloaded right now. This is the peak time, but you can see it is actually starting to generate the code. And it's slowly generating it. We'll come back to this in just a second. Once it generates it, notice it says use ggplot2, the iris data set, and create the graphic. And we'll let it continue to plot that. It's taking some time. It's overloaded right now. And basically, it gives us a graph like this. This is what I just showed you on the screen earlier. Setosa and sort of a mixture of versicolor and virginity. So let's take this a step further. I've got 3 different flowers here, and 2 of them overlap. I want to simplify this a little bit. To simplify that, I need to tell ChatGPT to only plot for species, Setosa, and versicolor. So this is the same command as before, but I'm now focusing it a little better. Generate the R code for a ggplot2 graphic that allows viewers to get an overview of the iris data set, but just for species, Setosa, and versicolor. And it looks like our first one's finished, but it looks like it got an error again. So I'm going to click on New Chat and start one for this restricted view, Setosa and versicolor only. Let's see if we can work on this one. And it appears that it's overloaded this morning. So I'm going to show you what it generated just yesterday. When I ran it, it gave me this answer. It says, here's an example of our code to create the graphic for Setosa and versicolor. It gives us a new plotting graphic. And it says, make sure you load the ggplot2. If you haven't installed it, do that first. And it gives you a description of what it's going to do. This is the code it generates. Let's go ahead and run this code in R. You can see ChatGPT is still struggling. Second. Picture back here. And let's copy the code in. And it's generated the code. The code we just ran, which was given from ChatGPT, is this fairly complex code on how to do a graph. And that graph now has the red data points on the left, Setosa, the right data points are versicolor. But what we had to do is focus our request to say, generate it only for the 2 species, Setosa or versicolor. So you have to be very focused when you're using this to get the exact result that you want. And what it will do is generate the graphic that we just saw. Let's do another one. little more complicated. We're going to use ChatGPT to generate a neural network on the species data. And to do that, I'll just say, generate R code to run a neural network on the iris data for species with petal length and petal width as the 2x variables, and plot the graph. So we'll give ChatGPT another chance. This is unfortunately peak time for it right now. And let's do a new chat. Notice we are, there we go. And let's give it a chance to see if it can generate the code for our neural network. And it looks like it's having some problems. The system is overloaded. So let's look at what it did for me yesterday. When I actually ran this through ChatGPT just yesterday, I got the following message. It says, using the data iris, the data set iris, we're going to actually look at the X variables, petal length and petal width, the Y variable is species. It's going to take the Y variable as a factor. It's going to scale it and run the neural network. I've already installed the neural network software. I'm going to run the library, the neural network. Make sure everything is running. And now let's see what the code looks like that came out of ChatGPT just yesterday. I'm going to load the data set, and this is the code you would have to write by hand. Talk about the implications of that in a moment. And run it. And it runs the neural network that quickly. So ChatGPT, when it's running, gives you the code necessary to run the analysis. Now, in this code, I asked it to run it for 3 flowers. Notice when I asked it to run ChatGPT, it just said run it on all the species. There were 3 different species. One of the flaws is it has 1 node here. 1 node. And it's hard to distinguish between the 3 different flowers. So you have to actually know enough about what it should be doing to know how to fine-tune it. Let's see if we can fine-tune this a little bit. It will give us the picture you see here. It has 1 node. So it took our inputs correctly. It created a 5-node hidden layer, but it has only 1 hidden node. So I'm going to ask it to do something different. I'm going to say generate R code to run a neural network iris data for species as a factor. When you say species as a factor, that means it's a text field for Setosa, versicolor, virginica, and it converts it to what are called dummy variables. That gives it a little more information. And we'll give ChatGPT a chance here for a second. See if it can actually handle it, if it's still busy. We'll look at the code. And it's still during its prime time. It's still a little bit busy. The code it will generate will look like this. It will tell you, here's a sample using the neural network package. Petal length and petal width are the X variables. Species is the Y variable. It's changing it to a factor. And it gives us this code. So now let's actually take the code it generated yesterday and put it into R. And it generates a new neural network. Let's look at the difference here. Now it has an output node for Setosa, output node for versicolor, output node for virginica. It'll give you the probability. Given a certain petal length and a petal width, what's the probability it's Setosa? What's the probability it's versicolor? What is the probability that it's virginica? The key here is we need to understand when it's doing things correctly and when it's not, and then fine-tune our requests to actually get the appropriate solution. And so you'll get a solution that looks like this, as I just showed. And now you can actually interpret the probability that given the petal length that you've measured and the petal width, what is the probability? It's one of the 3 different flowers. So what if we don't specify petal width and petal length? I just say run the ARC, generate the ARC code, run a neural network on iris data for species as a factor. What if you don't specify? Let's see how ChatGPT is doing. And it is definitely overloaded. That's why I always have this. And if we actually ask it that, it'll result in this code and much longer code. And it looks like this. Now it actually adds something to this. In neural networks, what you're traditionally supposed to do is have training data and testing data. And notice it actually sets up training data and testing data. 70% of the data becomes training data, 30% becomes testing data. We're going to copy this over and actually run it in R. This code was generated by ChatGPT. And it shows 97% accuracy. And so notice it did something slightly different. I asked it to run a neural network again. This time, it didn't give me a graph. It gave me the accuracy measure. How accurate is our neural network in predicting things going forward? So you have to be very specific. If you want to plot the output, you have to tell it to plot the output. Sometimes it defaults to accuracy. Sometimes it defaults to plots, but it is not necessarily consistent. So you have to be very specific when you're using ChatGPT on what you're trying to accomplish. Now, I actually ran ChatGPT with New Chat. New Chat clears out the history. And I said, do it with ChatGPT with New Chat. As we saw before, it'll generate additional code. This will just run the example one more time. I'm going to run this example. I'm going to show you that neural networks don't always work. So I ran New Chat, ran this model. It's going to take a little bit longer to run. The reason is sometimes neural networks get stuck and do not converge. That's the local optima problem. And although it says down at the bottom, accuracy 0, if you look at the warning messages earlier on, it says algorithm did not converge. It tried to actually run it and could not actually achieve a solution. So let's look at another problem. Just because you can automatically generate the code doesn't mean you necessarily get a good solution. Let's take a different technique, not neural networks, but something called support vector machines. Support vector machines is another way to do classification of the iris data. And to do that, I'm just going to run this command, generate R code to run an SVM, support vector machine, on iris data. Let's see. And I guess I should have waited longer. Here's our example that actually ran. It still gets an error message when it's trying to do the comment. It actually wrote the code for us, but did not give us all the comments at the bottom, which means it just ran out of capacity again. So let's try to do it with a support vector machine. Again, the system is definitely overloaded. ChatGPT, available by OpenAI, is now offering a pay-for-service where you can get priority speeds. I'm using the free service right now. And if we run this code through ChatGPT, it'll give us that, run that request. It'll give us this code. And let's see if a support vector machine can handle things. Now, notice it says we have to add some libraries and so forth. So I'm going to add that library to R. And we also need to install. ChatGPT often forgets to tell you to install things. So let's go ahead and run support vector machine. See how accurate it is in R. And it comes back with an accuracy of 97%. So you can run neural networks, graphics, support vector machines. Let's see if we can take time for one more example. I see a question on chat. Can you create a theoretical framework? You can actually request it to do anything that you want. Its knowledge base is based on 45 terabytes of data. Try it to see what works. Some things work better than others. The best way to find out if it will do a theoretical framework, conceptual theoretical framework, is to actually do it. We'll talk more about what the implications of that in just a few moments. So far we've done graphics, neural networks, and support vector machines. I'm going to do one last example with a different data set. Another classic data set for machine learning is called the Titanic data set. This is the passenger list from the Titanic. Who survived and who didn't. I'm going to actually ask it to run a logistic regression, not a neural network, but logistic regression on the Titanic data on survival as a function of age and gender. Let's give ChatGPT one more chance. And usually it comes back right away. At non-peak times, it comes back very quickly. So let's look at what it generated for me yesterday. It said, simply run the following model. But notice, I asked it, my request was age and gender, and down here, it changed it to age and sex. Its contextual framework says gender is the same as sex. The problem is my variables are not labeled that way. So it changed one of the variable names without actually investigating whether that's appropriate. So what I did is I reran it a second time. Generate R code to run a logistic regression on Titanic data for survived as a function of age and gender num. I created a new variable called gender num, not gender, which is a 0, 1 male and female. And I got the following result. Now it got it correct. It does a generalized linear model, survived as a function of gender, age, and gender. And if I actually run that code, this is the code it generated for me yesterday. If I actually run that code in R, this is a logistic regression, and it gives me the coefficients of the logistic regression. It tells me the intercept, the coefficient for age, but it's not significant. The coefficient for gender, it is significant. In this model, gender num is a 0 for female, a 1 for male. A negative coefficient means if you go from female to male, you lower your survivability. And as we know from the Titanic example, on the Titanic, it was women and children first. Gender was a key factor in survivability. These are a number of examples. Some of the things we've seen in these examples with ChatGPT is some of the things we've seen is first, you have to be very specific. You have to be very specific. And what we had to do in a couple cases is actually fine-tune our requests. When the request changed gender to sex, we had to be very specific and tell it, use gender num, a different variable that would not get confused with gender itself. It often generates results that are not necessarily accurate. It sometimes generates code that is not accurate. Let me explain what that means. The R language is an open source software package. Let me bring it up again. R is open source software. It changes frequently. It's not unusual to have new releases of it coming out 3 or 4 times a year. ChatGPT was trained on 45 terabytes of data in 2020. It's basically looking at versions and understanding of the versions of R from almost 3 years ago. As a result, it sometimes generates commands that are not compatible with the current version. So you need to be sensitive to that. The advantage is it rapidly generates code, and if you understand what the subtleties are, you can go in and fix it. Just as in this example with a neural network, we changed one output node to changing it to a factor, which creates 3 output nodes and corrects the mistakes. So you have the option of fine-tuning it and improving the models, but you have to understand the technology behind what you're trying to accomplish so you know how to refine it, how to fix it when it does not necessarily give you the answers that you want. Let's go back to my slides for just a moment. We went through a number of examples. There's a number of strengths and weaknesses of ChatGPT. Some of them I've understood, I've explained so far. Generally, it understands, and the Vice President of Machine Learning, Zheng Chen, has a report that went out that says it understands your intent, generally with high accuracy. You sometimes have to refine it to get it focused on what you really want. So you need to be very specific. Another strength is it tends to demonstrate very complex reasoning. When I asked for support vector machine or a neural network or a graph or a logistic regression, it understood the terminology and this was able to actually pull up the functions necessary to run that. One of the big advantages, it uses a single model for a variety of things. We just used it to generate code, our code to do analytics work. It can actually write articles for newspapers. It can do research for you. It can do a variety of things. This is a more general purpose artificial intelligence technique. It's not focused on just playing a game of chess. It gives you the ability to do very broad things. And it generates very coherent language. The language that we saw is it gave back code. It gave back descriptions. I'm going to bring that up one more time. In our example, go back and look at an example. After it generates the code in this box, it'll actually give you a commentary on what all this means. And it's a very concise, very thorough commentary. So it generates a very coherent language in the response. Some of the weaknesses that have been documented. It has a tendency to do what's called hallucinations. It starts creating things that are not necessarily factual. Experiments that are done on ChatGPT have to recognize it was based on 2020 information that was fed into it. If you ask it about situations that are occurring in 2022, it's not going to have the contextual framework, and it'll start pulling together information that's not necessarily accurate. It also has a very limited understanding of context, which sort of relates to that. If you don't have the necessary context of what you're trying to talk about, it gets confused. The examples I used today on the Iris dataset and Titanic dataset are very famous machine learning datasets, so it understands that. If you have something that's much more obscure, it's going to start losing the context. Zheng Chen also talked about it lacks controllability. You don't necessarily control the output. What you have to do is control your input and be very specific to generate the solution. Another issue that Zheng Chen also talked about is the memory gets stale. This data is from 2020. All of its contextual framework is from 2020. So if you start asking about more recent things, it's not going to be quite as accurate. Give you ideas of productivity improvements that people have been measuring for the past year using some of these tools. They found software engineers who use tools like this can actually code twice as fast because they put the request in, it generates the code, and all they have to do is fine tune or tweak the result. It's improving the productivity of software engineers by doubling how much code they can write. Some software engineers have been found to be able to generate a week's worth of code, sometimes in just one day. by using tools like this to assist them in writing software. Authors, newspaper writers, authors have found that they can actually write prose, write paragraphs, write articles twice as fast as before by using ChatGPT to start creating the structure of the articles. Economists in a 2023 article have been found to be 10 to 20% more productive. And a more recent article, call center operators using things like ChatGPT and other assisted techniques like this are about 14% more productive. These tools can enhance your productivity, whether it's software, writing articles, doing economic research, or even serving in a call center. And so as a result, there's tremendous productivity improvements. People have talked about the concern about eliminating jobs. I use the example of when automobiles were created, they eliminated jobs of the blacksmith who put together wheels for buggies and carts, but it generated more jobs of the people in the automobile industry. This is going to make people much more productive. It's creating more opportunities very quickly. But as you saw in some of the examples, you need to understand the background of what you're trying to accomplish so you can fine-tune the answers. I'm open to questions. I see one question.
Okay.
I can make the slides available if in fact you would like to have them.
Yeah, okay. Thank you, Professor Harter. And I saw a lot of interesting questions that they type in chat. Let's start with the first one that it's saying, thank you, Professor Donald, for this fantastic webinar, first of all. My question is the following. ChatGPT has demonstrated great results, still can provide us with inaccurate or wrong information. As right now, it is not a 100% reliable tool, but sir, do you think it will come a day that artificial intelligence chatbots will replace all the IT professionals, especially the programmers?
No, and here's the reason. Let me address a couple issues on the accuracy issue. I did experiments with ChatGPT when it came out. 3.5 came out in November, and it was about 80% accurate. That's a helpful tool, but not perfect. The new version 4.0 came out in April. It's 90 to 95% accurate. It's improving quickly. And so it is improving. That's improvement from just November to April in a short period of time, and made a huge jump from 80 to 90 and 95% accuracy. And the ability to replace people, when a gentleman named Henry Ford created an assembly line to create automobiles back in the early 1900s, they said it's going to replace people. Well, it replaced blacksmiths, but it generated new jobs, and it made people much more productive. And by being more productive, people earn more money, they could afford more goods and services and so forth. It actually raised everybody up. It raised everyone's up. It's going to do the same thing in technology. It won't replace IT professionals. As you saw, IT professionals still need to fine-tune the output, need to take their knowledge and apply it to help improve things. But I'll give you one more example. I'm old enough to know when we used to type papers in college on something called a typewriter. And a typewriter was very inefficient and very slow. And when word processors came out, and Microsoft Word and other packages, it sped things up. It did not replace authors. It allowed more people to be authors and more people to contribute. And things like ChatGPT will allow more people to actually start contributing and open up opportunities for others. It won't replace people. It's going to actually improve productivity and open up new possibilities for everyone.
Thank you, Professor, for this insight. It was very interesting. And going on, we have another question. And this person is asking us, I'd like to know if there will be any course going through explainability, artificial intelligence, and fairness ethics in artificial intelligence, as there are a lot of algorithms that have been found discriminating people depending on their gender, sexual orientation, where they come from, etc.
Right. So that's a very interesting question. It's a very important question that's being addressed right now. I mentioned ChatGPT used 45 terabytes of data. We often talk about megabytes and gigabytes, but we're now up to terabytes of data. In extracting all that information from the internet, books, magazines, and newspapers, there are biases in those sources. The biases in those sources will lead to biased decisions. And so researchers are trying to figure out how to fix that. ChatGPT is not totally automated. It has a lot of specialists fine-tuning the training to try to eliminate some of those biases. But that's a very important issue right now, and researchers are trying to figure out how to eliminate those biases in the decisions it makes.
Yeah, this is super important also. And another question is coming from Mike from Uganda. His question is, can I be able to generate an editable database using ChatGPT?
You can generate almost anything using ChatGPT. People have written articles with it. I know a lot of newspaper writers are now using it to do draft articles. You can start looking at designs of things, but it is limited based on its knowledge base. The best way to answer that question is go into ChatGPT when it's not really busy and actually type in that request and see what it can do for you. But as this is still using a 2020 database, as they start updating the database, it's going to have more power and more flexibility. I don't know that anybody really knows all the things it can possibly do yet, because it is still so new. So I'd suggest going to OpenAI, log in, create an account, and then actually try it.
Okay, amazing. And I will use the next question that is, will be issue NHS certificate of attendance? If so, where can we download it? We will reply to these questions in a few minutes. So just keep to listen to a few questions that they are still here, and then we will come back to you. Then the next question is, hello, is there a way one can create a conceptual or theoretical framework using ChatGPT? I mean the diagram.
Right. So the best way to actually do that is actually go to ChatGPT and try it. The examples I've shown you are in applied analytics, and those are the things that I've tried. I've seen demonstrations of writing articles. I haven't seen demonstrations of that particular example, but the best thing to do is actually try it yourself and see what it does.
Okay. And the next one is, excuse me, professor, would it be possible to have the material you showed in the masterclass? Antonio is really interested in your material, Professor Harter.
Sure. I can provide that to you and you can distribute that.
Nice. And keep going. Hello, can the research consumers assessors determine whether one has utilized ChatGPT services in their research? If so, how?
Yes, I'll give you an example. There was an article that I referred to, and I'm going to share my screen for just a second. And this article that's listed down here with the Brookings Institute, that article was actually started by the researchers using ChatGPT to say, how do I start to write a research article on this topic? And ChatGPT started to build the framework for them. And so one of the authors of that article actually used ChatGPT to start doing their research for them. And it went out and extracted the information and pulled the information together, and they use that as the starting point for their research.
Okay, thank you, Professor. We still have a few questions. Godfrey asks us, Every time I try ChatGPT create diagram, it fails. Is there a special way to ask it so that it can create the diagrams? Example, the theoretical framework diagrams. Can you show us by example?
Yep. I have not done any framework diagrams along those lines using ChatGPT. The fact that you've already tried it and it did not work, what I would suggest is using one of my favorite tools. You've probably used it before. It's called Google. Go to Google and see if anyone else has tried it. There are a lot of people out there who are trying things right now, having discussion boards on what's working, what doesn't, and how to get it to work. So I would suggest going that path. I haven't actually tried to do diagrams like you discussed for theoretical frameworks.
Okay, and they also ask us, doesn't ChatGPT violate research ethics in university?
So that's an interesting question. In doing research, what you're supposed to do is read the articles to find out what other people have done. That's essentially what ChatGPT is automatically doing. It's reading things and bringing it together for you. So instead of you searching through your library or electronic libraries and pulling things together, it's pulling things together. You still have to cite, you have to give credit to the authors of the original work. That doesn't change. But ChatGPT is a faster way of bringing things together. So let me give you an example. When I got my PhD in the 1990s, to do research, I had to go to a physical library, take books off the shelf, and read the articles. Today, PhD students download the articles electronically from an electronic library at the university. It's a different way of doing things. ChatGPT takes it one step further. It actually searches and gets the right articles for you and brings them together. So 30 years ago, I had to go to the library, search, and pull things off a shelf. 10 years ago, PhD students had to search electronically. Now ChatGPT is facilitating that search. It's the difference today between looking things up in a telephone book, if anyone's ever seen a telephone book, or going to Google and searching for someone's phone number. It's just a tool that makes you much more efficient. So it doesn't violate any ethics concerns as long as you give credit to the work that other people have done. That's the issue.
Yeah, right, Professor, thank you. And Daniel is asking us, I have used a lot ChatGPT, but most of the time I paste multiple questions, MCQS form. The ChatGPT shows mostly wrong answers, but using one by one, it shows correct results. Is it a drawback of artificial intelligence ChatGPT or something else?
So I have found, based on my experience, the more focused you are on a very specific question, the better it is. If you give it too much information, it gets a little confused. And so if you can focus things, imagine you're trying to tell someone directions of going from one location to another, and you give them very complicated directions, they're probably going to get lost. If you give them very simple directions, they'll probably get to the right location. I've found if you give it simpler commands, focused commands, it's more successful than if you give it a series of things and expect it to understand everything you're talking about at once.
Okay, and the last question is, thank you, Professor. It was a great webinar. Is there a way to get the reference text by ChatGPT while writing a research article?
Usually, it will give you information along those lines. If it doesn't, you'll actually have to basically ask ChatGPT what was the reference for things and see if that tells you what the reference is. There are some issues of how effectively they are storing that reference information. So that's sort of an ongoing issue, right?
Okay. Thank you, Professor Harter, for the answers to these questions. They were a lot. The students were really interested in this. And for all the people that make questions related to the master, We will receive soon a thank you email, and you will have there all the information that you asked for related to the Masters of Syracuse University. And so since we are at the end of this masterclass, you do get the chance to get the certificate of attendance. You will find the link in the chat. I just posted. So feel free to click the link and get your certificate. It was a pleasure for me to be in this webinar, and I hope it was useful for you all. And thank you, Professor Harter, for everything, for your time, and for the explication of ChatGPT and its mechanisms. Hope to see you to the next event. Thank you so much.
Okay. Thank you.
Bye.